Good morning and good afternoon and good evening to all our attendees joining us today for the latest IoT Central webinar. This is David Oro. I'm the editor and co-founder of IoT Central, and I'll be your host for today's event. I'd like to start our event off today by thanking Teradata for sponsoring today's webinar. We're honored to have Teradata sponsoring our event today and appreciate their contributions to the IoT movement and their support of IoT Central community. Today's webinar is entitled, What People Really Do with the Internet of Things and Big Data. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have two panelists, and I'll introduce them in just a minute. There will be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on iotcentral.io later this afternoon following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing and presenting them on your behalf during the Q&A portion of today's event. I'm very pleased to introduce today's speakers, Daniel Graham of Teradata and John Myers of Enterprise Management Associates. Dan Graham was an application developer in the 1980s and has had an impressive background in parallel database servers and software. In his current role as Enterprise Systems General Manager of Teradata, Dan is responsible for strategy, go-to-market success, and competitive differentiation for the active enterprise data warehouse platform and leads Teradata's technical marketing activities. John Myers joined Enterprise Management Associates in 2011 as Senior Analyst of Business Intelligence. In this role, John delivers comprehensive coverage of the business intelligence and data warehouse industry with a focus on database management, data integration, data visualization, and process management solutions. John has years of experience working in areas related to business analytics and professional services, consulting, and product development roles. John's passions are rooted in analytics associated with the events of business processes and the behavioral events of people to provide knowledge on various business models. Thank you both for being with us today. We look forward to the presentation. In today's webinar, we will be discussing what it takes to develop a winning Internet of Things and IoT strategy and avoid potentially being outflanked by your competitors. IoT is a huge market expansion that will hit $14 trillion by 2020. The Internet of Things market expansion is a chance to get in front of the competition. A robust IT initiative can move your company from the sidelines to market leadership. And all this means big data is getting a lot bigger. In today's IoT Central webinar, John and Dan will dig deep into real-world implementations and discuss the IoT research results from clients with real-world, hands-on implementations that illustrate the value of analytics at the intersection of big data and the IoT. You will learn the business drivers of end-user organizations implementing IoT, who are the champions driving IoT initiatives, popular devices being monitored with sensor data, discover which analytics are applied to sensor data, which analytic platforms are supporting IoT initiatives, how many organizations are already on their second IoT project. Dan and John, with that, I'm going to turn it over to you so you can begin as soon as you guys are ready.
Well, David, thank you very much. I appreciate that wonderful introduction and getting us kicked off with a bit of the agenda about what we're going to be talking about today. Just to give you guys a little bit of a sense of what we're going to be doing, we're going to give you guys an introduction into what IoT is. I think this audience will be pretty self-explanatory. And then we're also going to talk a little bit about the results of an EMA end-user research study that was a worldwide study where we're going to look at business drivers, the champions that are really driving those IoT initiatives, what are some of the workloads, the analytical platforms, and then starting and continuing those projects as you alluded to a little earlier today. One of the things I think that people, the one thing I think a lot of us have heard is, talking about those interconnected devices. I think it's anywhere between 20 and 50 billion. This particular estimate from Juniper Research is 38 billion by 2020. We're going to see this to be not just, I think a lot of people think in terms of wearables or some of those consumer devices, but there's a huge application in there for B2C or B2B scenarios of commercial devices, connected fleet such as trucks, ships, trains, putting in HVAC into our office parks and our large industrial buildings, because it's one thing to look at business to or B2C types of use cases like a thermostat for my home, but if I control 5 or 6 different buildings across a large office park, that really starts to become economies of scale for saving money. And if we look at this, we're seeing almost $14.4 trillion worth of value associated with, mainly with in terms of process efficiency and operational productivity, in terms of how can we reduce some of our costs, how can we improve our operational performance. So when we look at those things, it's not just about the devices, but it's about the components that bring those things together to create value. And that's really some of the things that we see represented in the EMA survey. In terms of how the Internet of Things works, Dan, I believe this is one of the slides that you guys have brought together from the way that we look at the difference between the edge and the information technology stack.
Yeah, thanks, John. So we wanted to have a couple quick level sets of the Internet of Things. Not everybody understands the market or the technologies. This is the high-level managerial view, which basically shows the things, and things are any major object. Let's think in terms of a manufacturing line, perhaps a cell tower, perhaps a utility tower that's transferring electricity across the countryside. Can be your car. Your car has an interesting behavior because, 6 computers in your car, if you've bought one in the last couple of years, and the car is mobile, so it doesn't sit still like a manufacturing line or a utility pole. And all of these devices are feeding data off the sensors into what we'll call the gateway. Now, the gateway ranges from a simple router all the way up to a powerful Dell 5000 server or something from Hewlett-Packard, different servers, but these are rugged servers. These are not the ones you find in the data center. And those servers collect sensor data. They react to the sensor data in real time, but the other thing they do is they send the data home. They call home and they send the data to the data center, whether your data center is in the public cloud or it's on premises. In either case, there's a lot of things you do with that data once you get it into the data center, and one of them is analytics. In the last couple of years, about the last year and a half really, the market analysts have started shifting their attention from the general deployment of sensors and networks over to the analytics, and the reason for that is fairly straightforward. That's where the majority of the return on investment pops out. Once you analyze all this data and turn it into value, the ROI on that particular aspect is very high. A lot of the work you do out there at the edge, and the edge means the edge of the network, if you're not familiar with that. So we're kind of getting out there into the wild. You might have wind turbines on the side of a hill or somebody out on an oil platform in the middle of the ocean. Well, that's not exactly your normal intranet or even your internet. So this edge is the edge of the network where the things are. So let's look at a more detailed view of this same thing. And what we're seeing here is that, there's some applications here for the data center people to work on. On the left, there's an awful lot of things going on in the edge, in that gateway. So we have all the devices with their sensors. And remember that one of these devices can have anywhere from 1 to 10,000 sensors attached to it. So like a building, for example, might have 10,000 sensors. You might have 50 sensors in just one room. So as you go through this, you're seeing a lot of sensor data. It's going either to a control system, which is sort of the older proprietary style of manufacturing systems and operational systems. But nowadays it's migrating to this gateway notion, which is more open and commodity-based technology. That data goes into this green stack, which is where we have to have the security, the device management, and the data streams. And I think we saw this shutdown of the Internet, basically. A lot of major domain names were shut down about a week or so ago. all of that derived from a mess going on with the security of these devices. So security has got to become foremost in everybody's mind about these devices. If you hear nothing else today, take that away. Make sure you protect your company and your customers. In the middle, there's some applications and some data management and some policy enforcement. These are all applications, operational applications that your IT department's going to have to deal with, because now they're managing those devices and they're managing the security and the process control associated with them to the degree that they at least react to the gateway. They don't manage the machines or the things directly, but they do manage the gateways. And then on the far right are some capabilities that would be called analytics. Analytics itself being the raw algorithms, the data warehouse that houses a lot of interesting data, and the data lake, which is often the place where the data originally arrives. So with that, John, I think we're coming back to you.
Yes, sir, we are. And a lot of what Dan has just talked about is very important to some of the things that we're looking at. So one of the questions that we asked as part of our survey was, what were the IoT initiative business drivers? And for the most part, most of these business drivers were about how can organizations help to make themselves more process efficient or more operationally productive. This isn't necessarily particularly a sexy aspect of that, of running a particular business, but it is something that really takes this concept of taking sensor data and saying, what do we do with it? Why have we collected it? Why have we pushed all this sensor information out to our manufacturing plant, out to our hospital, out to our mining operation, and says, we're doing this so that we can help to either increase our revenues, reduce our costs, or manage our overall margin better than our competitors can do. And this kind of thing gives you a good sense of how that's working out. Dan, I know that you guys at Teradata have helped a lot of organizations who have looked at these particular problems, and you're really helping them to not just think of it as a strategy, but to take that strategy and turn it into a tangible implementation.
Well, absolutely. Thanks, John. If you looked at your first bar up the top there, the increase the product or service quality, that's kind of what this story is about. So we have a high-tech semiconductor manufacturer here that we worked with, and they had grown rather rapidly over the years, but not in exactly the way that was planned. And so what ended up happening was they had a lot of fabrication plants, they call them fabs, all over the planet. They started out organic in one location, they grew, they opened another one. Before long, they had a lot of installations. And each one of them was sort of an island to itself, and the data that was being collected was really trapped in that location. And so as they tried to bring this data together in order to analyze it, they found that they had about 30,000 files every day spinning out of these fabrication machines. So if you're aware of fabricating these semiconductors, these big wafers, it's an enormously high-tech process with many steps and complex stages. And so they really had about 30,000 files, about 20 megabytes each was coming out of these machines, and they really couldn't consolidate. They really couldn't look at what was going on. This happened to be about the time we acquired a company called Think Big, and Think Big is an open source Hadoop consulting organization. And they at the very time that this was happening, Teradata had their data warehouse there, but at the same time, Think Big was building an infrastructure for consolidating the data. And what it turned out to be is now called it's being named Kylo. It's an Apache project. It's incubating. It's new open source. And what it really does is it goes out into those locations and it sort of gathers all those files, checks them in, puts them into a massive zip file, or if you will, and then ships them into the home office so that they can account for where all the files were, which ones were missing at the time of shipment, get those into the staging area of the data lake. Now, once they get all this data into the data lake, they have sort of an unpack reversing process where they say, okay, let's see, what did we get? Well, we're missing 3 files. We're going to have to do some data staging, some cleansing and preparing of that data, which eventually leads to the data warehouse, connecting up with the data warehouse, and between the data lake and the data warehouse, they are looking very carefully at improving the yield of their manufacturing line, which basically means less and less failure in the manufacturing of these wafers. And so the consequence is they have much higher yield quality now that they're able to put a giant microscope behind this and say, okay, now I know exactly what's happening, where our concerns are, where we can improve the quality. Back to you, John.
Yes, sir. So one of the things that when I was putting together the end user survey about what was really driving IoT was the thing about who are the champions, who are the people within the organization that are really moving IoT initiatives forward. And to me, it was kind of interesting. Sometimes we think about IoT being very much a technology-based initiative, but if you look at the business drivers that we had as the front part, it's not surprising to see our operations, whether that be logistics or quality, being our number one IoT champion, followed closely by general management and administration, and that has technology in our third position, or basically 1 out of every 5 champions are from that particular group. So it shows that the people that are really driving the initiatives to say, hey, this is why we're going to have an IoT program, this is where we're going to get the value from our IoT program, are from the organizations that are directly responsible for that operational process efficiency, and that operational productivity, so that they can continue to get better. A lot of times when I talk about what IoT really does, say for a manufacturing organization or for a healthcare organization, is to take those current quality programs, whether they be lean manufacturing, whether they be some form or fashion of TQM or Six Sigma, and really inject not just data into those programs, but real-time data into those programs, so they can continue to drive farther and farther down into the value that are their operational processes, such as supply chain management and things of that nature. To this end, I think we start to run into a bit of contention between the folks that are in our operational teams and our information technology teams. And there are, sometimes I think Dan and I have talked about this in the past, it's the hard hats versus the laptops. And sometimes, particularly if we're talking about oil and gas, or we're talking about distributed energy generation, you've got guys that have been line foreman for utilities for many, many years, and now you've got these guys coming in and going, hey, we've got these sensors, we can kind of help you with these programs and things of that nature. And the IT guys kind of go, well, without us, this wouldn't make any sense to you. So sometimes we see a little bit of contention here between the OT and the IT groups. But I think that when they both realize that they need to work together to make these programs be truly effective, that's where you see a lot of the great value that comes out of these initiatives. And now I'm going to hand it over to Dan, who's going to talk a little bit about Teradata's experiences managing these groups.
Yeah, I think it was a good point, John, that there is some culture clash between these groups. Ultimately, IT needs to be a service to the operational technology people. They need to make the OT people feel comfortable. They need the operational technology people to see the benefits to them, because that's the business. That is the majority of that company's business. It's not the IT group. So in this particular example, we had a customer that was building some extremely large vehicles. We have quite a few customers doing that, actually, and using the sensor data to predict machine repairs, which also harkens back to one of your earlier statistics, that this is a popular use case, particularly in manufacturing and other places that are like that. And so this machine had, tons and tons of sensor data coming out every day. And what was going on was the data was going into a data lake. It was going into a Hadoop system. And the engineers of that organization were sifting through that data, trying to figure out which parts would fail, why they failed, was there interactions between different parts that caused the failure, so that they could prevent any possible failure in this vehicle. Of course, they never want these expensive vehicles to stop running or to disappoint their customer. And so this was certainly a right thing for engineers to do. And you'll see this theme often, that it's not just a matter of predicting the maintenance, but it's also the prediction of failures that allow us to design better machinery so that that doesn't happen again. So the problem that we found was that in this customer, the business users, the other side, the line of business of this triad, didn't have any access to the sensor data. And the reason was simple. The sensor data was in a data lake. The business users don't write Java. There was this big gulf, and there was no access to data. It just so happened at the same time that this was going on, Teradata released this query tool, this query feature called Query Grid. And you might think of it as a federated tool or a data virtualization, so that the business user could take like Tableau or MicroStrategy or Cognos or one of the favorite tools that they have in the business and access from the data warehouse into the data lake. So two parallel machines are exchanging data and joining it together in not real time, but near real time. And so a simple business point-and-shoot tool would allow them to combine this data. Well, lo and behold, the business people who had never really talked to these engineers before had to ask a lot of questions. What's going on with this data? What's this data mean? Why does it behave this way? And this created a bond. This created a relationship between two cultures that really hadn't worked together before. The outcome was that the business people were then able to schedule maintenance, schedule labor, parts delivery, all the things that they needed because they had the predictive maintenance data. But the more important thing was this bridge between cultures created 10 more use cases for that same data. So the ROI, the payback, immediately jumped up as the business and the engineers started working together. John.
Yes, sir. So you talked a lot about how we can start to, we've talked about devices, we talked about the value, we talked about the business drivers and the champions. Now we've got devices that are starting to provide us with information. What are people doing with that? And that was another one of the key aspects of the research that we did. Now, it was kind of interesting when I was developing the survey and really looking at it. We had a side bet with one of the people that was helping me develop the survey, and they were convinced that no one was going to be using any of this information at this point in time above, say, a discovery stage. It was all going to be operational visibility to say, hey, how is that airplane performing? Where are those trains located? Talk to me about where I'm at with my supply chain, et cetera. And I was kind of convinced from a particular perspective, because I come much more from an advanced analytics big data perspective, that people were going to be using it for that higher level of information. And to our surprise, we actually found that people are using the data from their IoT initiatives across a wide range of perspectives. There was no one true winner that said, hey, this is the only thing that people are using it for. As you can see here on screen, our dark blue areas are where we're talking about operational visibility. I like to talk about that in terms of, say, RPMs of your car. How's the engine on your particular car doing right now? The next stage up is saying, based on the type of engine that it is, do we have the RPMs in the right range for the speed that we're going? Anybody who remembers driving a manual stick shift automobile, if you over rev the engine, it's time to shift and things of that nature. The next stage up is looking at, hey, that speed, where is that relative to where we are at with our business rules and our processes? It might be one thing that we've got a really nice RPM for the speed that we're driving, but if we're going 85 and a 55, that's probably not the best idea for the safety of our drivers and things of that nature. The next stage up is that data discovery, that red line kind of in the middle. These are large amounts of brand new data sets that are being presented to organizations. And much like we've seen over the last couple of years with big data, there are people who are kind of going, what can I do with this information? What are some of the things that I can do with it as I look at this particular perspective? And I like to talk about this particular workload as sticking my fingers in the data and kind of pulling it one way, pulling it in another direction. And I think that as our operations teams in particular get some visibility into, hey, this is what this information can mean to us, that will really ramp up the adoption about what people can do. Because I think to a certain extent, sometimes our IT teams will be very proficient at collecting data, storing data, curating data, things of that nature. But to a particular respect, they don't really understand what's the value inside of those particular perspectives. And oftentimes it takes an operational team member or a line of business executive to say, hey, this is what that means, and if you can show me a pattern like that, we can start to track that information, much like Dan was talking about preventative maintenance. If we go into those light blue categories, we start to get into something that would be in that data lake, data warehouse component of Dan's architecture, and saying, hey, how can we take a look at the performance of our assembly lines by line, by plant, by geography, and then look at it all across the entire group. We start to look into prediction and pattern matching and things of that nature. So there's no one particular one that jumps out other than that, hey, how about our operational coordination? But, just being 2 out of every 5 or just a little under 20%, that doesn't really say, hey, this is the one true thing. What's really coming out is that with all the data in these IoT initiatives, people are using it across a wealth of different areas. Now, with that data and with those obstacles, we start to see something that I like to refer to not necessarily as a best practice, but as a best pattern. And I think that when we look at what we've done in the past, whether it be big data, whether it be our traditional data environments, there are some core concepts that are really jumping out to us again. Privacy is number one on our list of obstacles of people implementing IoT initiatives. In B2C environments, that's going to be very key because you're going to have that similar, hey, opt-in, opt-out type of concept that we see along the lines with our social media. Device users uncomfortable with data collection, that kind of goes in that same area. In B2B environments, we see that being a little bit less important, or if you will, a showstopper, because to a certain extent, when we are working with contractors, when we're working with employees, a corporation can set the mood for what's going on with that. But it is interesting to see some of these same practices that we see across multiple implementations that we have today. If we can take those patterns, look at how we would implement them in IoT, we can start to use our past learned lessons and use them for these future considerations. Dan, I'm going to hand it over to you, and you're going to talk about how Teradata has helped people solve some of these problems.
Yeah, I think I'll get to that in a minute, John. I know you weren't expecting this next statement, but I want to make a shout-out to everyone about EMA and the quality of the survey. I mean, we are providing information here, John's providing it, on what people are really doing. And I've purchased about 7 surveys this year, funded about 2/3 of those, and I have to say this is the best one we've got. It's the most thorough, it's the most accurate, it has the best number of responses, and these answers are answers that you can take back to the strategic planning or the department managers and say, here's what we want to do. So thank you, John. This is really good work. And for everybody that doesn't know EMA, this is actually very low cost as far as surveys go. So, John, you should raise your prices because they're half of what everybody else is charging.
Well,
anyway.
We'll definitely do that, and thank you very much, Dan, for those kind words.
Yeah, well, I believe it sincerely. All right, so let's talk a little bit about, one of these kinds of use cases that leans towards the analytics, which John talked about 2 slides ago. And this is a company that builds these large machines. This particular machine is a paper grinding machine. It takes in the pulp, the chemicals and all of the things that it has to have to create paper, and it generates cardboard and bond paper and tissue paper and any kind of paper that the manufacturer who buys it wants to do. This machine is actually the length of a football field. It's gigantic. It has most of them have 10,000 sensors on them because there's a lot of pressure and heat and chemicals and nasty things happening to this pulp as it goes through the processing, and so they need to monitor it very carefully. Now, this particular customer of ours had a data warehouse on SQL servers, so they didn't really want Teradata's data warehouse. They didn't really have the same kinds of needs of some of the mega companies in the world. But they did have a need to figure out what was going on inside this machine, predominantly because their customers, the people who buy these machines, don't want downtime. If this machine is as big as it is, it costs as big as it does, the idea is to keep it running 24 hours a day, every day of the year, nonstop. Well, of course, with all that pressure and heat and those nasty chemicals that transform the pulp, they have things that wear out. So two things happen. You have unplanned shutdowns where, this is catastrophic, alarms go off, all the bosses are called, the headquarters are called, everything gets exciting. And then there's the planned shutdowns where they can sort of manage that. And what they have there is something called consumables. So there's these felts and belts and parts and rollers and things that get replaced on scheduled maintenance time. So one of the things that they started doing was condition-based maintenance, which is the predictive maintenance that you heard about. It's actually a larger application than predictive maintenance. And so the predictive maintenance was saying, here's when we need to schedule downtime. Of course, there's all this humming and hawing. We don't want that, but we have to have it. And then they also started benchmarking the consumables. And what they found was, as they went to Portugal and Germany and Asia and different places, the same machine in each location was behaving differently. And why was that? Well, the analytics that we put in place, which was really just software, which is a software solution. It's called Aster, if you want to know. And the software solution would analyze all this sensor data and came back and said, well, here's what we know. This is what's wearing out, how fast it's wearing out. This is why we have to have the planned downtime. And lo and behold, they discovered that what was happening was that there were certain knockoff consumables. There were competitors that were selling these lower quality belts and felts and what have you. And while they were cheaper and procurement was happier, what it was doing was causing more frequent repairs and planned downtime. Lo and behold, the lower cost of the goods was actually costing them more money in terms of planned shutdowns. So with this information, this company was able to equip their sales force with these reports, go back into their customers and say, that knockoff you've been buying? Well, if you buy the more expensive one from me, we can actually save you a lot of money. And saving them a lot of money meant fewer downtimes, fewer planned downtimes. It also meant $35 million return on investment in the first year for just a simple analytics software package that gave them all this information about the sensor data. So the good news is, it pays off. It pays off pretty quick. John?
Excellent. Thank you, sir. Now, one of the things that, again, kind of went with that side bet that I had with the person helping me to develop my survey was, what were the platforms that went along with this? And if you hearken back to the workloads chart where we saw we have this wide range of workloads and people, what they're doing, we found that only 3% of our respondents were not using that entire stack. They were kind of focused in that operational visibility component of that. And so here is a bit of a taste of what are some of the platforms that really allow organizations that as they pull the sensors, so we have sensors, we have collection points, whether that be at a manufacturing facility or a hospital, then moving that to a regional, and then kind of moving all the way back to a centralized data center, whether that be in the cloud, on-prem, et cetera. These are some of the platforms that are being used for that analytical processing. So not surprising, we saw data discovery being our number 2 overall workload. Data discovery platforms are our most popular aspect of that. Next one down is analytical databases and platforms. Oftentimes you'll see these being implemented, whether it be a columnar technology and in-memory technology, both of them put together, to show that speed of response. Because a lot of times if we're talking about sensors, we're talking about a certain desire for a low level of latency. And then the enterprise data warehouse, not surprisingly to see that particular platform being used because organizations, when they pull information from these sensors, particularly as Dan pointed out, if we go out into an oil field environment or we go out into, say, a smart infrastructure type of environment, that's not exactly room temperature attached to electricity and with free, with ready available access to bandwidth like they are, say, in my house. And so in those particular instances, we're going to need to augment the data that comes from those sensors with information about customer, about product, about region and store and things of that nature. So this gives you a sense of the wide breadth of platforms. And this kind of goes with an EMA concept we call the hybrid data ecosystem, where there's no one platform that really maneuvers all of these pieces, but rather it is a combination of these platforms, oftentimes sharing technical and business metadata together to really bring it out. So to be able to do data discovery workloads, to be able to do predictive analysis, and to do those types of operational visibility components, you're going to need a mix of these platforms across a wide spectrum.
Yes, well, given this is a Teradata sponsored event, you can see why I was excited by this survey. One of the answers is we use an awful lot of different analytics to make these things happen. This is my business. This is what our company does. But let's take a little tour of how this happens in the real world. So look at this truck on the left. This basic machine here, this isn't your everyday Ford or Chevy. This is a fairly large vehicle. It basically has in it roughly 2,400 horsepower. It picks up 300 tons of ore, of dirt out of the ground, and they're looking for gold, and they're looking for copper and molybdenum and different kinds of ores, and it moves at about 3 to 7 miles per hour. And as they're digging for this metal out in the hillsides, what they have to do is they have to build their own roads. Nobody builds a road for this kind of work. And the result is that you have these people out there all day long, sort of like the curling event in the Olympics, that are constantly repairing the roads and making them better and capable for this machine to move at 3 to 7 miles an hour. And that's because when you have 300 to 400 tons of dirt, you can sink right into the ground if you don't keep moving. So it's like quicksand. If you don't keep this machine moving, bad things happen. Now, for the longest time, this company was using Teradata dashboards to manage an awful lot of what was going on inside their mine. And basically, they collected all the log files. They understood all the truck transits, the location, the load levels, the operators. They had all of their logistics in these dashboards coming out of the data warehouse on a constant basis. And this was like every 15 minutes there was a refresh of data going into the data warehouse from the sensor data, from the trucks, from the crushers, and throughout the mine. Well, that was a data warehouse. That was really cool, and they'd run their business for a long time on that. But even more cool, they added to it, and they added a data lake. And that data lake started doing some very interesting things in even faster real time. So now what they've got is another 100 and some sensors on this big monstrous machine. And every time anything happens at 3 miles per hour, that data goes into the data lake, goes into actually HBase if you want to be specific. And it collects that data and very quickly responds to what's going on. So it sends out messages to the operator sitting inside the cab, sitting inside there driving it. So what's happening now is the operator of the machine, the driver, is being told, look, shift into 13th gear and slow down a little bit. Okay, shift into 12th gear and speed up a little bit. You need to brake a little bit more on the next curve because we've seen some problems on the prior trucks that went through there 15 minutes ago. So all this information is given to this person because they really can't afford to have this thing sink into the dirt. They really can't afford to block the few roads that they've had to build for themselves. And the whole point here is to get the ore off into the smelters, into the areas where they can dig out the gold and the copper and whatever metals that they have. So here you see a circumstance where, as John said, people are using all these platforms. Well, in this case, 2 of these platforms are working together on the same machine in the same 15 minutes. And the customers have dashboards, and this customer has dashboards and tools throughout the environment and radio headphones on the driver of this massive machine. So it's a very positive environment for analytics.
Excellent, Dan. That's one of my favorite use cases that when we talk about. I mean, it's, you never really think about dump trucks sinking into the ground if they stay in one place. And I think that's one of the things that probably, for an OT team is very self-evident. Hey, these things need to keep moving. They need to keep moving down the pipe, and something that other parts of the organization may not fully understand. They may not understand, hey, we want to be sure about predictive maintenance about those trucks, but we also want to make sure that they're not sinking into that roadbed, or how can we maximize that roadbed aspect of it. In terms of projects, one of the things that we ask as part of our surveys at EMA, which is kind of unique to the way that we do things, is we ask individual organizations about the multiple projects that they have. So again, project objectives, as of right now, we're seeing a high level in terms of that operational productivity and that process efficiency. Supply chain efficiency is going to be very important, not just, say, for manufacturing, but if you think about it, healthcare has a particular aspect of supply chain efficiency and management that goes along with that when you think about medications, when you think about blood supply, when you think about some of the very perishable aspects of a healthcare organization. If you think about where we're going with green energy production, managing the amount of supplies that we have in particular areas, that's very important into that. But we're also seeing, as what we've talked about in terms of, hey, how do new business models get established? How do we see new products being created from this data that we have? It's very important. From those projects, we also ask people how many projects do they have. Now, something that Dan and I have talked about quite a bit over time has been, moving from that first or second project into the third, fourth, fifth, and beyond, because sometimes it's relatively painful, if you will, to initiate that first project, because you have to get your sensors, you've got to get your backbone set up, you've got to get your data collection streams going, you've got to get all that information so you can get that first taste. But as you go on to the second one, onto the third, and onto the fourth, one, you're going to be learning from and having lessons learned applied from those earlier engagements, and two, you already have that infrastructure that's been created so that you're only making those next little steps. So while it can be for those IoT champions, it can be difficult to get them to get that first, if you will, that first score, that first win. As they build that momentum within the organization, both culturally and architecturally, they can pull out larger and larger value from the infrastructure that they've developed. One of the more interesting things I think that we're going to hear about today is how Teradata is helping a very popular car manufacturer do that very concept.
Well, I want to back up on you here, John, because I think this is one of the more telling slides, one of the more powerful statistics that you've discovered, which is that if you're not in those 2 projects and 3 projects and 4 projects, you're falling behind your competition, because people aren't doing these 2 and 3 and 4 IoT projects because they're losing money. They're doing it because they're making money. They're doing it because the payback is worth the trouble. So getting over that hump, as John said, in that very first project is hard to justify the project. It's hard to get the information to the execs so they take action because it's expensive. It's not a low-cost endeavor to get going. You probably do need to do things differently. So I think this is a powerful slide that says, what's the smart money doing? The smart money is doing 11 projects already. What is the next smartest money doing? They're doing 5 to 8 or 10 projects. And so IoT is really popular once you get going. And I think, John, this is one of the most startling statistics. When I first opened the survey, I said, wow, this is perfect information for everybody to see. So thanks for that. And yes, let me just mention this company in Sweden. Everybody knows about Volvo. Volvo has a reputation for being the safest car on the road. Always has been focused on that, but that really began in about 2007, 2008 to expand enormously by consolidating a lot of data marts into a data warehouse where the Six Sigma engineers could then paw through the data and start enhancing the quality of the product even more than they had done before. So using this rather strong quality-first attitude, Volvo really upped their game dramatically in the last 8 or 10 years to increase the product capability. But look at what's happening now. It's their goal that by 2020, these machines will not crash anymore because of anything except driver error. So the machine will not ever be the reason for a crash. It won't be that a tire doesn't work correctly or a brake doesn't work correctly or the suspension's a little wobbly on an icy road. In fact, what they're doing today is they've put Wi-Fi into these machines, and if you opt in, and 80% of their customers have opted in, more than 80 actually, they've opted into a program of gathering this data and sharing this data. So it turns out that Volvo cars will talk to each other as they're driving down the road. And if you're in Sweden, of course, there's a nice long winter there with a lot of ice on the road. One Volvo car will talk to another and say, guess what, Dan? On this particular patch up here, there's a little more ice and I feel some skidding. I'm adjusting for it, but you should be aware of it. And the other car says, yep, I know what's going on. And it starts changing the braking and the suspension a little bit to deal with that ice. I mean, it's amazing that they can even think of such thing. And here they're already implementing it. And they're using sensor data all up and down this machine to do that. Because ultimately it's not a car, it's a machine. It's got several computers on board, hundreds of sensors, and the idea that the car should never crash, they're trying to extend that to the least reliable part, which is the person. They're even watching the chin and the eyes of the people in the modern cars to see if they start nodding off and shaking, seeing if they can say, wait a minute, you're falling asleep, let's wake you up. So there will come a day that sensor data is used to make these cars 100% safe. And I can't wait. I think it's fabulous. And with that, we will turn this over to David Orrell.
Dan, John, thanks for the excellent presentation. We've got 2 slides here. I'm going to come back to this slide in a second, but in the meantime, for those in the audience, if you have any further questions, here's John and Dan's contact information. We're going to get started with today's Q&A session, and I wanted to thank the audience for their participation. We have many great questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. During this Q&A session, I'm going to go back to that other slide, but leave this slide now. So if you want to capture their contact information, this is it. So let's get started with the first question. It comes in, how mature does your organization need to be to implement concepts like predictive maintenance?
Well, I think I'll kick that off from what we're seeing in our survey, and then I'll let Dan kind of talk a little bit more about that. I think that the concepts of predictive maintenance are, if you will, on a maturity scale of 1 to 5, or closer to 3.5 to 4 than they are as part of that initial step. I think they're a great goal for organizations to say, hey, ultimately this is where we want to be. But when you start to censor on your first or second project, predictive maintenance is going to be something where, one, you're going to have to accumulate a certain amount of data to really understand how you're going to be able to do those types of things. So as you start those lessons learned of being able to collect data, being able to understand how they work operationally, then when you have a certain pool of data to look at that. So I would say if you're starting in your first or second step on a maturity ladder or maturity curve, if you will, predictive maintenance is going to be something that might be a little farther away than you might like, but I think it's a great thing to look at, because as Dan pointed out, if you have these significant assets in your business, and you can make sure that they're online as much as humanly possible, then that really helps to bolster both your predictable revenues and to manage your costs. But Dan, I don't know if you've seen anything different, but I would say that it's a 3.5 or 4 out of 5 on that maturity level to do that.
Yeah, I don't do the surveys, John, so I don't know how many companies are doing it. I do know that a lot of them start with condition-based maintenance, which is basically you have your repair team, and then you have this analytic software that gives you some insight based on the sensors. So predictive maintenance is just using predictive analytics to get to that goal. I will say of a personal experience in my general manager days at Teradata, the Teradata machines, which are usually racks of Intel servers or Dell servers, massively parallel, we actually do predictive maintenance so that our customer support knows anywhere from 40 to 60 days in advance that this disk drive on server number 7 is going to conk out. So we can then go in and negotiate with the customer, well, when can we have a chance to turn off that particular server and get at that disk drive? And, of course, just like that pulp grinding machine, no customer wants to take the machine down. They always want it to be up 100%, which is why giving them forewarning and advance notice of, when this is important allows them to set their priorities, manage the circumstance, and then allow our repair people to go in. So we've been doing this since about 2005 using some software called Axeda. I think some of you may know about Axeda. I happen to notice one of their employees is on this call today. So, it's just something that's been going on for a long time. It just is a question of whether or not your company's gotten around to it yet. Next question, David.
Sure. This is kind of related to, I guess, what you guys are talking about and when do you bring in predictive maintenance, but it goes back to the beginning. What is typically the first step for an organization implementing IoT?
Well, the initial step is, I guess, you start from the beginning in that putting sensors into your environment, and I think that this would become remarkably more easy. Not to give them props for starting this whole thing, but really to say that when General Electric said that we are going to be fully invested in their concept of the industrial IoT, and they're going to be putting sensors in jet engines, trains, a lot of the things that they're manufacturing, I think that gave credence and if you will, cover to a lot of other organizations to say, hey, this isn't just a fly-by-night thing. If GE is going to start doing this, we're going to start doing it too. And GE is going to enable us to have those sensors in all those devices. I am also seeing a lot of creativity in organizations that are saying, okay, if we have, say, a legacy vehicle, how do we put sensors in it so that we can get some of the same value? And I'm seeing some very creative people who are putting sensors in legacy trucks and not doing it in terms of, hey, we got to rewire the whole vehicle, but saying, hey, can we put a sensor in the wheel well, or not in the wheel well, but physically in the wheel of a truck, and it will help us monitor not only the speed of the vehicle, but it'll help us to look at how well it's bouncing up and down the road. So whether it's got a nice flat ride, whether it's got a rough ride, things of that nature. And oftentimes you kind of go, hey, I wouldn't have thought about that, but there's an example of somebody who said, I can't retrofit every Parks and Rec truck in America to be like a Tesla, but what I can do these wheels get replaced a lot, and so we can work in that particular area and provide something relatively easy to do. So first step is going to be those sensors. The sensor information has to flow somewhere, and then that information needs to start to be analyzed. But that's the first step, is really, and I think it's become remarkably easier for organizations to sensor their manufacturing floors, sensor their fleets, sensor into their non-fixed assets, say in a hospital or in an apartment or an office park.
So the next question that's coming from the audience actually kind of speaks to that. You're talking about sensors. They create all this data. The question becomes, how do we know that the data that we are acquiring is good and meets our needs, or the IT team's needs, and it's not something that we don't want to present, and how this affects the quality of the data?
Well, so this is where, in my opinion, we look at the value of our best patterns and apply them to new areas. So I've talked with organizations. We see it in our data that for the most part, their organizations have good trust in the data that comes from their devices, but there is an issue when humans either configure them wrong or humans use the devices wrong. So there still is a certain amount of data quality issues with it, because to a certain extent, when you get data from a sensor, it's either a 1 or a 0. It's either good or it's corrupt and it's bad. And generally you can fix that either from a transmission perspective or something like that. But if I'm pulling from an RFID or a barcode reader that has a GPS associated with it, and I have a human who has to pull the trigger and or use it in a particular way, then we start to look at that particular component. And I've actually talked with a package delivery firm not located in North America, but they found it rather odd that when they were doing their operational visibility, they could see packages being delivered in the middle of the street based on GPS, but when they looked at the quality or is the delivery being done appropriately, customers were very happy. So they went out and they asked the drivers, and they said, "So can you explain how we see this?" And they go, "Oh, well, to be more process efficient, we scan the devices while we're driving, scoop them up in our arms, and then we walk in and deliver them so we can be done with our route faster." Management was happy because the guys were trying to be much more productive. The IT guys who were looking at the data went, "Okay, let's look at where the GPS is going like that." HR looked at it from an operations perspective and said, "Okay, guys, you can scan packages, but not while you're driving. Maybe at a stop sign or a stoplight, but please don't do it while you're driving." But in those particular perspectives, you have to look at the data, much like in telecommunications or in mobile application development. We look at the data, make sure that it meets our needs, and we might go, "Hey, this doesn't make sense," but when we pull back and we go, "Oh, this is how the process is really working," now we can start to readjust what we want to do and decide if we need to initiate a data quality program or whether we need to change the way we look at the data that we're pulling off the sensors.
We have time for one more quick question here, and then we'll wrap it up. So are there efficient methods for taking legacy machines and integrating IoT sensors to them?
Say that again, David?
Are there efficient methods for taking legacy machines and integrating IoT sensors to them?
Well, I think creativity is the number one. Like I said, when I talked with the organization that was retrofitting legacy trucks with sensors, not deep within the truck itself, but really saying, okay, what are we trying to measure, and then saying, okay, we can do that in a wheel as opposed to on the chassis and things of that nature. So I think organizations are really looking at some of the value that goes along with that. I think that when we start to see that initial creativity, I think we're also seeing organizations that are starting to make that demand of their supplier to say, "Hey, I expect there to be sensors on the devices that we have." They may not initiate them initially, but they will start to say, hey, this is going to be something that's going to be a requirement for us to make a purchase, because if we want to get into IoT, as Dan pointed out, it's going to be a competitive advantage thing, and if we don't have that capability, then we will inherently be behind. So I think that organizations, as they replace their plant and equipment, will make those types of choices. If they have the legacy plant and equipment, like the question implies, we're going to see some very creative ways that organizations can pull data from these existing platforms and then make them really work out. So I think, Raspberry Pi is a good example of the types of beds that we can use. I think we need to harden those just a little bit more when we go to, say, a steel mill or an oil field, or even into some hospital settings. We need to really harden those, but I think the Raspberry Pi concept is a good one to use when we say we want to start moving forward.
Great. I think we're out of time here. Thank you both for great answers to some very good questions. For those of you that asked questions that weren't answered today, we will be sending all unanswered questions to Dan and John and the Teradata team so that they can follow up with you after today's webinar. I just have a few quick announcements. Please mark your calendars for November 29th, our next IoT Central webinar sponsored by BitStew. Also, today's taping will be available for on-demand viewing later today and can be found on the homepage of IoT Central at iotcentral.io. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and special thanks again to Teradata for their sponsorship and our speakers today. Dan and John for their insights in today's topics. My name is David Oro. I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on November 29th. Have a great day.